In this video, we will solve trigonometry problems in 2 dimensions, and hopefully majority of this lesson will feel like a review as opposed to you're learning something new, because all these ideas were covered in the grade 10 academic course. So let's talk about the trig tools which you will use to solve a triangle. So when we're talking about solving a triangle, we're solving for the angles, or the interior angles, or the side lengths. So it depends on what kind of triangle you have. If you have a right triangle, right away I'm thinking of 2 different trig tools I can use to help me solve the right triangle. So you can have the primary trig ratios, SOHCAHTOA. Okay, another tool that you have when you are presented a right triangle is the Pythagorean theorem. So that's a squared plus b squared equals c squared. Okay, now if you don't have a right triangle, then you probably shouldn't think of SOHCAHTOA, the primary trig ratios, or the Pythagorean theorem. So if you have an oblique triangle, which is a non-right triangle, if you have an oblique triangle, you're thinking of either, hopefully remember, the sine law, which is a over sine angle A equals b over sine of angle B, which is equal to c over sine of angle C. And of course, you could take the reciprocal of all 3 ratios and generate another version of the sine law. And then you have cosine law, which is c squared equals a squared plus b squared minus 2ab cosine angle C. Okay, so those are the tools which you have available to help you solve a triangle. So if you have a right triangle, you either think of the primary trig ratios or the Pythagorean theorem to help you. Now if you have an oblique triangle, then those tools that I just mentioned are probably not the best choices. So you're either thinking of the sine law or the cosine law. And more specifically, when should we think about the sine law? Okay, when do we use the sine law? And when do you use the cosine law? So I think knowing when to use a cosine law is a little easier. So the scenarios for the sine law is either side, 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 or side, angle, side. Okay, side, angle, side is 2 sides and a contained angle. And side, side, side is pretty clear. You have all 3 sides of the triangle and you're going to solve for an interior angle. Now what about sine law? When would you use a sine law? When you have angle, side, angle, angle, or side, side, angle. And if you don't remember these scenarios, like angle, side, angle, side, angle, angle, side, angle, side, 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 or side, angle, side, if they all sound like the same thing to you, and if you're totally lost on a quiz and you're given an oblique triangle, just use the sine law or use a cosine law. One of them is going to work. So if you use a cosine law and it doesn't work, then guess what? Then you probably should use the sine law. So that's the worst case scenario, and I wouldn't suggest that, but that's what you have to do if you didn't know the conditions for each trig tool. Okay, but try to remember them. And if you do the homework questions, it becomes pretty straightforward. All right, so let's try to solve these problems. So I didn't pick the easiest problems because I felt like this was review, so hopefully we don't find these too challenging. Okay, so we have parallelogram ABCD, has side lengths of 22 centimeters and 65 centimeters. The length of the diagonal is 77 centimeters. Determine the area of the parallelogram. Okay, so let's draw ourselves a beautiful parallelogram. Not drawn the scale, of course. So we have A, B, C, D. Okay, beautiful. And we have, let's say 65 here. And we have 22 here. And then the diagonal is BD. Or you can do an AC. I'm just going to do it as BD. So the diagonal is 77 centimeters. All right. And they want me to find the area of this parallelogram. Well, the area of the parallelogram is the base of the parallelogram times the height. Now, I could choose AD as a base, but I'm going to choose DC as the base. Okay, so what is the height? What is the height? The height, we'll start from vertex A. All right, so that's the height. Okay, we'll say, there we go. That's the height of the parallelogram. In fact, you know what? Let's just do this. So 65 centimeters, and we'll call this E. So AE is our height of the parallelogram. All right, perfect. Okay. So how do we go about solving for the area of the parallelogram? There are quite a few ways to do this. So what I'm going to do is I'm going to study the triangle BDC, okay? I'm going to study the triangle BDC, and I'm going to solve for angle C because I have side, side, side. If I'm studying triangle BDC, if I have the angle C, I can solve for angle ADC because these two angles here are supplementary. Now, how do I know they're supplementary? Because it's a parallelogram, right? Okay, these sides are parallel, and of course they're the same length. So these two angles, it's the C pattern you learned from grade 9. So these two angles, angle ADC and angle C, is they're supplementary because they're co-interior angles. So once I solve for angle D, I can solve for the height of the parallelogram. I can solve for AE because if you look at this, I have a right triangle. Okay, which means I have angle here, the angle ADE, and I have the length of the hypotenuse, so I can solve for the length of the opposite side. And once I have the height, I have the base, I can solve for the area. So here's the game plan. Step 1, solve for angle C. Step 2, solve for angle ADC. Step 3, I'm going to solve for AE, which is the height of the parallelogram. And then step 4, solve for the area. So that's how I generally approach these problems. I generate a game plan, and then you execute it. Now, if you can't generate the game plan, if you can't plan that many steps ahead, then what you can do is just do what you can. Like I have 3 sides here, so just pick any, like just solve for angles, and hopefully eventually you'll get to the answer, which is area of the parallelogram. But try to devise a plan. Don't just mindlessly solve for things. Only do that if you're totally lost. Okay, let's execute the plan. So I'm going to solve for angle C. So we have 77 squared equals 65 squared. So we're using cosine law because side, side, side. All right, so here we're going to do, I'm just going to rearrange everything. And just like last year in grade 10, I am going to hold on to the value using my calculator. So it's exact as possible. Okay, boom, that's step 1. Mission accomplished, solve for angle C. Now I have to solve for angle ADC, okay? So angle ADC is supplementary with angle C, so I can solve for angle ADC by taking 180 degrees and subtracting it by angle C. And that makes sense because of the C pattern, okay? They're co-interior angles. So that's something you should remember from elementary school or grade 9. Okay, now I have angle C, or sorry, I have angle ADC, and I can use a sine ratio because I have a right triangle here. So sine of angle ADC is equal to opposite, which is AE, over the hypotenuse, AD, which AD we have because that's 22. So AE equals 22 sine of angle ADC. All right, we're super close. We have the AE, so the area of the parallelogram ABCD is equal to AE times DC, base times height. So you can say AE, just do this, times DC. All right, so now I'm gonna use my calculator. So I'm gonna solve for angle C. Oops, sorry. I'm gonna solve for angle C. So 77 squared minus 65 squared minus, oops, I forgot the square. Minus 22 squared, 5 by negative 2 times 65 times 22. Oh, I forgot a bracket here. Okay, and then inverse cosine, and then take 180. So what's supplementary to 115? 64.7. Beautiful, 22 sine of that. And then take that and multiply by C, which is 65. 1,293. 1,293.4, let's say. So therefore, area of parallelogram ABCD is approximately 1,293.4 square centimeters. Okay, for example 2, we have two ships leaving the harbor, the first at 12 and the second at 12:30. The first ship sails on a course of 30 degrees east of north at a speed of 25 kilometers per hour. The second ship sails on a course of 20 degrees east of south at 15 kilometers per hour. Determine the distance between the two ships at 14:30. Okay, so this question requires us to remember a bit of our knowledge about bearings from grade 10. So the hardest part I feel for this question is the diagram. If you can interpret the situation and draw the corresponding diagram, then you pretty much answer the question. Okay, so you have first ship leaving the harbor at 30 degrees east of north. Okay, let's go a little further. Then you have another ship that leaves at 20 degrees east of south. Okay. And you're trying to find out the distance between the two ships at 14:30. Okay, so this is the harbor. This is where the first ship ends up. This is where the second ship ends up. And if I can solve, and I think it's pretty easy to solve for the distance the first ship travels and the second ship travels, I can see like a side angle side scenario, which will be perfect to use cosine law for. Okay, so this AH is basically B. So how far does the first ship travel? Well, it travels at a speed of 25 kilometers per hour for 2.5 hours. So 25 kilometers per hour times 2.5 hours. That's 62.5 kilometers. Okay, so we know this is 62.5 kilometers. Let's write that in. All right, what else do we know? Or what else we want to solve? We want to solve for HB, which is A, because this side is across from angle A. Okay, anyways, the second ship travels for 2 hours because set sail at 12:30 and it's 12:30 to 14:30, so it's 2 hours at a speed of 15 kilometers per hour. So we're looking at 30 kilometers. So it doesn't travel nearly as far, which makes sense because it's for lesser time and he's going slower. All right, so now I want to solve for angle H, which is not that bad because I have a straight angle here. So 180 degrees minus 30 degrees minus 20 degrees. (180 minus 50 is 130. Perfect. Like I said earlier, side angle side. I can solve for h, which is the distance between the two ships. So we have 62.5 squared plus 30 squared minus 2 times 62.5 times 30 times cosine of h. All right, one step with a calculator. So we're looking at about 84.95. Okay. On the test or quiz or assignment, I'm going to tell you how much to round it to. But for now, let's just say 2 decimal places. Therefore, the distance between the two ships at 1430 is approximately 84.95 kilometers. And you know what? That seems reasonable. Yeah, because that angle of 130 degrees, that makes an obtuse triangle. And, yeah, it makes sense. 84.95 seems very reasonable. All right. Okay, for the third example, in triangle RST, angle T is 90 degrees and angle R is 20 degrees. A point Q is located inside the triangle such that SQ equals TQ equals 20, and angle QST is 30 degrees. Determine the length of RQ. Okay, so for this question, I definitely think a diagram would be a great idea. So let's start with triangle RST. All right. So let's say angle R here, RST. So angle R is 20 degrees and angle T was 90 degrees. A point Q is located inside the triangle such that SQ and TQ, so this is Q here, SQ and TQ are both 20 units. Okay, perfect. Angle QST is 30 degrees. All right. And what's the question asking for? Determine the length of RQ. Alright, so what I want you to do now is pause the video and try to devise a strategy on solving for the length of RQ. Okay, try your very best to build a game plan. And then once you have the game plan, execute the game plan. Okay, so hopefully pause the video and devise a brilliant strategy. Now your strategy may be different than my strategy, but this is how I'm going to approach to solve for the length of RQ. Alright, so I'm going to start off by focusing on triangle QST because I have so much information here. Okay, let's solve for angle TQS, and then you have all three angles of triangle TQS, and you have two sides. So you can solve for length of TS using sine law or cosine law, whatever you please. And then we can solve for RT because triangle RTS, or sorry, RST, doesn't matter. RST is a right triangle. So solve for RT. And then you basically have side angle, solve for RQ. How do I know what angle RTQ is? Because angle RTQ and QTS are complementary. So if I know that QTS is 30 degrees, then RTQ is 60 degrees. So that's basically the game plan. We just have to execute it now. But that was the hardest part to the problem, I think. All right, so let's solve for angle TQS is 180 degrees minus 30 degrees minus 30 degrees. And that is triangle angle sum theorem. Okay, triangle angle sum theorem. And for the one above, I forgot to mention for this one, sorry, you guess, I mean, it's no harm in providing a rationale. You can say straight angle theorem, because a straight angle is 180 degrees. But these are theorems that you learned in grade 9 geometry, in the grade 9 geometry unit. Okay, all right. So the angle is 160, so 120 degrees. So I'm going to solve for ST using the sine law. I could use a cosine law, but I'll use a sine law. So ST over sine of angle TQS, which is 120 degrees, over, so equals, let's say 20 over 30 degrees, sine 30 degrees. So ST is 20 sine 120 degrees over 30. Sine 30 degrees. Oh, keep forgetting sine here. All right. Sine 30 degrees. All right, so there's ST, but that's not the goal. The goal is to solve for RQ, but to get there, I'm going to solve for RT first. So tan of 20 degrees, right? Opposite, adjacent. So it's ST is equal to ST over RT. I want to isolate for RT, so RT equals ST over tan 20 degrees. All right, now we're getting closer, and angle RTQ, and RTQ is equal to 9 degrees minus 30 degrees. Complementary angles. Which is 60 degrees. Okay, so now I know angle RTQ is 60. I have TQ. That was given to me in the question. I have RT. So now I use cosine law. So it's going to be QT. So let's say 20 squared plus RT squared minus 2 times 20 times RT times cosine of 60 degrees. All right, let's find RT first. So it's ST, which is 20 sine 120 divided by sine 30, and then divide that by tan 20. So this here, that is RT. $86.9. And there we go. RT is about, RQ is about 86.9. So there you go. That's the lesson on the 2D trig problems. And we're just basically going over the tools that we have, which will enable us to solve either a right triangle or an oblique triangle.